Yo, 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 guys, hello, and ladies, hello, yo. All right, we're going to work on equations with the distributive property. So we're not learning anything new today. It's just adding prior knowledge that we've already learned about the distributive property into solving equations. Now, here's what I wanted you to write down for distributive property. This right here is an example of the distributive property. Okay, so whenever we have multiplication, this is a number times, that's why it's next to parentheses, other stuff that's going on inside the parentheses, but there's multiple terms inside the parentheses. That's when we distribute and we multiply by everything inside the parentheses. So a times b plus c equals a times b plus a times c. Okay, and the same thing with subtraction. So that is an example of distributive property. An example with numbers is if I had like 4 times x minus 1. Well, that's 4 times all of x minus 1. So I have to distribute this 4 to multiply it by everything inside the parentheses. So that'd be 4 times x, which is 4x. 4 times negative 1 is negative 4. So this simplifies to this. Combining like terms is when we combine the same variable raised to the same power. So I can combine 2x and 3x to make 5x, but I cannot combine 2x squared and 3x to make 5x or 5x squared because they have to have the same power. Okay, so now let's look at some examples of some problems. So here I have parentheses inside, I have the variable on both sides. What we always want to do is just get rid of those parentheses first. And I know order of operations says do parentheses first, but I can't do anything inside of these parentheses with x minus 5. But I want to get rid of those parentheses by doing some distributive property. So this is 3 times everything inside the parentheses. So I'm going to do 3 times x, which is just 3x because it shows 3 times x. And I'm also going to do 3 times negative 5, which is negative 15. So this piece right here is simplified to this. Then what I'm going to do is I'm going to bring the rest of the equation down like we've always done before. Now that I brought the rest down, what I want to do now is look at the left side of the equal sign and look at the right side. And I just want to combine like terms to make this look a little bit more simple. So I look at just the left side of the equal sign, I only have 1x, I don't have anything else. But I have this negative 15 and this positive 1. Well, negative 15 and positive 1, I can combine those to make negative 14. So I have 3x minus 14. I'm going to bring down my equal sign, and I still have 2 plus x on the right because there's nothing to combine on the right-hand side. Now we're right back to where we've been since 7.1. I can subtract x from both sides just to get my variable to the same side. I'm left with 2x minus 14 equals 2. Whoa, that was weird. Add 14 to both sides. I get 2x equals 16 divided by 2 to get x equals 8. So there's a lot of steps here. First, the distributive property, combine like terms, moved our variable over. A lot going on, but it's all the same steps that we've already learned. There's just multiple steps now. That's why it's so important to show your work. Okay, so for the second one here, let me erase some of this. Second one here, I have nothing really to do on the left-hand side of the equal sign, but on the right side, I've got these parentheses. So I need to do distributive property to get rid of those parentheses. So this is negative 4 times everything inside my parentheses. So negative 4 times k is negative 4k. Negative 4 times positive 1 is also negative 4 because a negative times a positive is negative. And then I'm just going to bring down this minus 3 because I haven't done anything with it yet. I'm going to bring down this 5 minus 7k. Now I'm going to look at combining my like terms over here because there's nothing to combine over here, but I can combine like terms on this side. So I'm going to bring all this right back down. There's a lot of rewriting in this, and that's okay. It's a good thing. That means we're showing that we're simplifying it one by one. Negative 4 and negative 3 makes negative 7. And then now again, we're right back to where we've been with a lot of our equations. I'm going to add 7k to both sides because those cancel. I'm left with 5 equals. So that gives me 3k minus 7. Add 7 to both sides. That gives me 12 equals 3k, which means I got to divide by 3, and k equals 4. Now, yes, because 12 divided by 3 is 4. I'm going a little bit faster through this part because this is the stuff we've been doing for a few weeks, and we have a few videos on this stuff. I'm only going to spend a lot of time on the beginning because that's the only part that's new. Now, sometimes what's going to happen is you might have a fraction outside the parentheses, and you also have parentheses, and we don't like fractions. I don't like fractions. So in this case, what I want to do is I'm going to multiply by the denominator in order to get rid of the fraction, and I have to do it to every term. But here's the trick on this. So I want to multiply by 4 because that's my denominator, so I can get rid of it. But whenever we multiply and there's parentheses, we don't actually multiply the term inside the parentheses. We only multiply the term that's being multiplied on the outside. And the reason why is by multiplying by this, when I multiply this by all of this stuff in the inside, it's distributing that 4 that I'm multiplying. So the point is that I'm only multiplying by 4 on anything that's outside of the parentheses. So I'm multiplying 3/4 by 4, and I'm multiplying -2 by 4. I'm not multiplying inside the parentheses. So these 4's cancel out. I still have the 3 there, and these parentheses are also still here. 4 times -2 is -8, and these parentheses are also still here. Because I changed the value that's being multiplied from -2 to -8, now when I multiply, it's going to change that answer when I do distributive property, which is why I didn't have to multiply it initially. So now I got to do distributive property on both sides. So I got to do 3 times x, which is 3x. 3 times -13 is -39. Bring down my equal sign. -8 times 9 is -72. -8 times x is -8x. And again, we're right back to a normal equation with the variable on both sides. I can add 8x to both sides. I'm left with 11x minus 39 equals -72. I can add 39 to both sides. I get 11x equals, let's see here, -33. Divided by 11, x is -3. So after all that, x is just -3. Okay, so make sure to get rid of those parentheses, but if you want to have a fraction outside those parentheses, you want to get rid of the fraction, you can multiply by that denominator, but you have to do it to only the values on the outside of the parentheses. Try this first one on your own, please. So pause the video, try it, see how it goes. So I'm going to distribute. I'm going to keep the sign with the 9. So I'm going to treat this like a -9 because it looks like a -9. I know it looks like -9, but I'm going to treat it like a -9. So I'm going to distribute -9 to everything. So that's -9y minus 18. And I'm going to bring down my y minus 5 equals 3 minus 9y minus 18. Okay. Now I'm going to combine my like terms. So I have this 3 here. I got this -18. That makes -15. And then now we get to just solve. Add 9y to both sides. I get 10y minus 5 equals -15 plus 5. 10y equals -10, which means y equals -1. Okay, definitely 100% pause this one, try it out, and see how you do. So pause it. If you haven't done so, pause. Okay, there's your solution. X equals 6. There's the work. Check your work, see where you went wrong. Okay, finally you'll have word problems. The Coleman family had their bill at a restaurant reduced by $7.50 because of a special discount. They left a tip of $8.90, which was 20% of the reduced amount. How much was their bill before the discount? Okay, so let's take the original bill. So we're going to start with B. There's the original bill. And it was reduced by $7.50. So reduced means we took $750 off the original bill. So this is how much their bill was. They had the original amount, but it was reduced by $7.50 because of a discount. Okay, well they left a tip of $8.90, which was 20% of the reduced amount. So 20% of this amount. This is my reduced amount, right? Because if I take the bill and I subtract it, the $7.50, this is their final bill, the reduced amount. But I have to figure out what 20% of this is. Whenever you want to know a percent of a number, you multiply it. I got to multiply this by 0.2 because 20% when I move the decimal over twice is 0.2. So 20% of their bill was equal to $8.90. And that's how they figured out their tip. Now I can distribute this and solve from here. But we're just going to go ahead and call that good. Here's your independent practice that I want you to work on. Thanks to remember, parentheses first. Parentheses first, which means distributive property first. So I'll even put distributive property in parentheses. I spelled it wrong. There we go. Okay, that's all I got for you guys. Thank you for watching. If you have any questions or need anything, let me know. That's it. Curtius out.